Ozone is one of the important greenhouse gases influencing climate change on global scale. It is also a key constituent of pollutants produced through chemical and photochemical reactions in the atmosphere. Biogenic volatile organic compounds, including isoprene and monoterpenes, sensitive precursors of ozone, are oxidized to produce new gases, liquids, and particles. Especially secondary organic aerosol, or small-size particulate matter in the atmosphere. And energy is important for all atmospheric constituents and their changes, so we can develop an empirical model of ozone concentration with energy method. This model makes it possible for us to study the photochemistry of ozone and biogenic volatile organic compounds. We choose the Qianyanshe subtropical Pinus plantation, Taihe County, Jiangxi Province in China as our survey place. A 45 meters tower was built in this Pinus plantation for flux, solar radiation, and meteorological measurements. And ozone concentrations, biogenic volatile organic compounds emissions and solar radiation were measured from May 22, 2013 to January 4, 2016. Based on the principle of photosynthetically active radiation energy balance, the ozone empirical model considering isoprene and monoterpene roles are developed, respectively, for processes associated with photosynthetically active radiation transfer above the canopy are considered. 1. Photosynthetically active radiation attenuation due to biogenic volatile organic compounds. Isoprene and monoterpene terms represent photosynthetically active radiation attenuation by isoprene and monoterpenes and described as the following formula. 2. Photosynthetically active radiation absorption and use due to other gases, liquids and particles, when they are taking part in chemical and photochemical reactions through hydroxyl radicals and water. Water vapor is used as a surrogate to represent all absorbing gases, liquids and particles, and the photochemical term expresses the entire energy use, associating with all atmospheric constituents. 3. Ozone absorption in the visible region is described as 4. The scattering of gases, liquids and particles is described as the following formula. S and Q are solar diffuse and global radiation. Scattering factor. The ratio of S and Q describes the relative amount of gases, liquids and particles in the atmosphere, including gas molecules, aerosols, clouds, haze and rain. The photosynthetically active radiation energy balance at a horizontal plane is described by equations 1 and 2 for considering the roles of isoprene or monoterpenes, respectively. Then, the ozone empirical models considering the roles of isoprene or monoterpenes are developed as to determine the optimal photosynthetically active radiation energy interactions and distributions in the atmosphere between ozone and its driving factors, strict criteria for observational data were used. 18 and 8 samples were obtained and used in the development of the empirical model of biogenic volatile organic compound emissions for considering isoprene and monoterpenes, respectively. It also provides a reliable dataset to study the interactions between ozone and biogenic volatile organic compounds. Furthermore, the EMBE model can also be used to study the multiple interactions in ozone, biogenic volatile organic compounds, aerosols, and photosynthetically active radiation. We analyzed the observed ozone concentrations, biogenic volatile organic compound emission fluxes, solar radiation and meteorological parameters to develop the ozone empirical models. In Table 2, there are coefficients and constants, coefficient of determination, average and maximum of the absolute relative bias, normalized mean square error and standard deviations of calculated and observed fluxes for the ozone empirical model considering isoprene and monoterpene roles, respectively. Generally, the simulated ozone concentrations agreed with the observation for considering the roles of isoprene and monoterpenes. Because biogenic volatile organic compound emissions are extensively carried out in typical forests in China, we can use the observed dataset obtained from the REA technique to validate the model. Two methods were used to evaluate the ozone empirical model. Firstly, the mean half-hourly variation was calculated by averaging half-hourly ozone at each time of the day for May 22, 2013 to September 11, 2013. The simulated ozone concentrations overestimated the observations by about 30%, and their averages were 53.8 and 41.2 part per billion, respectively. It is reasonable considering the uncertainties in biogenic volatile organic compound measurements of about 25% as well as ozone and solar radiation measurements. Secondly, the calculated and observed ozone concentrations in single measurements in 2013 were also compared. The mean calculated and observed ozone concentrations were 57.7 and 41.8 part per billion, and the simulated ozone overestimated the observed ozone by 36%. Based on the above validations, the simulated ozone concentrations were in reasonable agreement with those observed, and the empirical models can be used to estimate ozone. Ozone empirical models considering isoprene and monoterpene roles give reasonable estimates of ozone. The interactions between ozone and its driving factors can be studied extensively from this model. The observed photosynthetically active radiation and ultraviolet have positive correlations with the photochemical term, but water does not absorb visible and ultraviolet radiation. Thus, the photochemical term represents absorption and indirect use by gases, liquids and particles through hydroxyl radical during chemical and photochemical reactions. Hydroxyl radical produced in many ways in the visible region, such as the reaction of nitrogen dioxide and water. Under the ratio of S and Q less than 0.8 conditions, strong positive correlations were also found between observed monthly UV, VIS, PAR and water vapor pressure at this forest. Results reveal the point of view that ultraviolet and visual identity system utilization is caused by all gases, liquids and particles through photochemical reactions with hydroxyl radicals and water vapor, and ultraviolet plays more important roles than visual identity system because of its higher frequency and higher energy. Hydroxyl radicals react with almost all atmospheric gases, liquids and particles, especially volatile organic compounds. Visible energy is absorbed and consumed by gases, liquids and particles in a single gases, liquids and particles phase and gas, particle conversions during chemical and photochemical reactions. Many gases, liquids and particles are visible radiation absorber. Others without visible radiation absorption react with hydroxyl radicals, and these absorbers, thus, consume visible radiation indirectly. The most important thing is that hydroxyl radical recycles quickly. This part energy is expressed by the photochemical term and determined by analyzing observational data and using the multiple fitting. The meaning of the photochemical term displayed in equations of model is the direct absorption and indirect use due to all gases, liquids and particles in the atmospheric column. When an ultraviolet empirical model is used to calculate ultraviolet at the surface and consider 1. 2 terms are photochemical and scattering terms. 2. 3 terms are photochemical, ozone and scattering terms. The relative errors of monthly ultraviolet are 4.1% for 2 terms and 3.7% for 3 terms. The annual mean ultraviolet loss calculated with a 2-term equation and 3-term equation are 0.57 and 0.54 million joules per square meters, respectively. Findings indicate that photochemical terms can express the role of ozone when ozone is not explicitly displayed in the 2-term equation. This feature was assumed to be existed in the visible region, and photochemical term described photosynthetically active radiation utilization due to all gases, liquids, and particles in the whole atmospheric column. One important issue should be mentioned that there is no evident correlation between the absorbing term and scattering term. Therefore, the photochemical and scattering terms are independent and can be used to describe the photosynthetically active radiation absorbing and scattering roles related to the absorbing and scattering gases, liquids and particles separately. Biogenic volatile organic compound emissions vary with photosynthetically active radiation and temperature. Biogenic volatile organic compounds react with hydroxyl radicals and BVOCs and produce new gases, liquids and particles. More than 30,000 biogenic volatile organic compounds are released from vegetation and interact with other gases, liquids and particles in photosynthetically active radiation. Numerous atmospheric constituents change in 3 phases all the time, and many mechanisms associated with chemical and photochemical reactions are still not clear. But the one important point is that UV and VIS radiation is a very important energy source triggering the chemical and photochemical reactions. No matter how the chemical compositions and reactions change, The energy associated with their main processes is a basis to drive their changes in the whole atmosphere. Therefore, the empirical energy method was selected to study the complicated interactions in ozone, biogenic volatile organic compounds, water, other gases, liquids, and particles, photosynthetically active radiation. Photosynthetically active radiation and the energy interactions controlled the changes and interactions of ozone, biogenic volatile organic compounds, and other gases, liquids, and particles. It is an advantage using the energy method because we pay attention to only their energy roles, and do not need high or low concentrations of biogenic volatile organic compounds and ozone. It saves much time in the calculations of the concentrations, chemical and photochemical reaction rates, and photosynthetically active radiation utilization of gases, liquids, and particles. The empirical model of ozone is a specific model for one site currently. It is a beginning using energy method to deal with the complicated ozone and biogenic volatile organic compounds photochemistry, and more studies need to be conducted in other forests. To improve the simulation of ozone, the air mass used in the ozone term was multiplied by 2 for hourly the ratio of S and Q greater than 0.7. Then, ozone concentrations were calculated using these modified empirical models for considering the roles of isoprene and monoterpenes, respectively. For considering isoprene's role, the calculated ozone still overestimated the observation, but the relative bias decreased to 23% and root mean square error was 18.9 part per billion. For considering monoterpene roles, the calculated ozone underestimated the observed by 5% and root mean square error was 16.0 part per billion. To understand chemical model performance over China and East China, there are comparisons between the simulated and observed ozone concentrations. 1. The root mean square error values for hourly ozone simulation are 21.6 and 41.0 part per billion using the model's 3 community multi-scale air quality. 2. Yi et al. Report that the root mean squared error value is 37 microgram per cubic meter for ozone simulation in 7 days using the weather research forecasting coupled with chemistry model. In general, the performance of the empirical model of ozone is in agreement with these chemical models, though there are differences in time and space scales. To further investigate the performance of the energy method and the ozone empirical model, the emission fluxes of isoprene and monoterpenes were considered together as biogenic volatile organic compound term to develop a new ozone empirical model. The corresponding coefficients and constant, as shown in Table 3. It can be seen that similar simulations of ozone were also obtained in comparison with considering the roles of isoprene or monoterpenes, respectively. Based on the principle of photosynthetically active radiation energy balance, the empirical models of ozone concentration for considering the roles of isoprene or monoterpenes were developed for a subtropical coniferous forest. The calculated ozone concentrations were in agreement with those observed with relative biases of 7.4% and 9.1% for considering isoprene and monoterpenes, respectively. So our ozone empirical models were validated very well.